Okay, so if you want to go back and read something about the Greek alphabet, it is there. You can go read it. I'm not going to read it to you, but it just tells you a little bit about it, why it's important, and it's kind of universal. The only one that's going to come up today, I believe, is theta. Oh. There we go. All right. Should know where it is. All right, so just the lowercase theta. It looks like a 0 with a line through it. Hopefully it isn't brand new to you, but it's what's coming up today. Okay. All righty. So this is called angle introduction because it is introducing the angles from a trig standpoint. And this is what's going on 97th. Yes, in the unit circle. Yay, unit circle. All right, so some of this is already filled in for you. I like when you have to actually write some stuff, but we're going to underline and kind of make sure we know, because this vocabulary is very important that we understand this fully. All right. So this angle right here, remember you can draw angles on the coordinate plane. Right? When you do that, this is in standard position. Understanding what standard position means is important. Okay, so its vertex is at the origin, and one ray is on the positive x-axis. Right? So you've got, here's where one ray has to be. It has to be on the positive x-axis. Angles are made up of two rays that share a common vertex, right? So we can refer to the sides as the ray or the sides. It's kind of interchangeable. So this angle opens up this way. See this little arrow here? Your vertex is at the center. One ray is on the positive x-axis. Okay, so we start at 0, go around counterclockwise, and that makes this angle right here 125 degrees. It's in standard position because one of the sides is on the x-axis, on the positive x-axis. The other one's over here. We all good on that? Yes? All right. So then we have what is called a reference angle. Reference angle, because we don't necessarily want to deal with all of the really big angles. It is the positive acute angle. It's always positive, always acute. Okay, it's formed by the terminal side. Oh, I didn't even highlight that here. The terminal side is where you end. So you have the initial side, and then this is the terminal side. Okay, so it is formed by the terminal side and the x-axis. And it doesn't matter which part of the x-axis, just the terminal side and the x-axis. It is the shortest way back. So the reference angle is always the shortest way back to the x-axis, not the y-axis, the x-axis. So that makes this angle right here. So if this is 125 degrees, to get to here is 180, so this angle measure would have to be what? 180 minus 125 would be 55, so this is 55 degrees. Plus it says it right there. Okay. Positive acute angle formed by the terminal side and the x-axis. So when you go counterclockwise, your angles are positive. When you go clockwise, your angles are negative. This is always starting at 0 when you are looking at them as in standard position. So we have what's called a coterminal angle. So we've got a terminal side, that's where we stop, right? So coterminal means that it's got the same terminal side. It's again in standard position with the same terminal side. So to get to this same spot, I could start here and go clockwise to get to here, and that one is negative 235. So important words here. Standard position, reference angle, coterminal angles. We all okay with those three things? Yes? All right. So let's look at these three pictures here. I'm going to make you write this one again. This is in standard position. So this right here is the initial ray. Or initial side. Okay, it's using the word side up there in that picture. I'm going to use ray right here because it could be either one. Okay, then if we start here and come around this way, that makes this the terminal ray. Initial ray and terminal ray. And you need to glue all that later and be with me right now. Everybody good? Okay, so then this right here is an example of a positive angle. So to come from here around here. When it is positive, that means that you have a counterclockwise rotation. Counterclockwise rotation. And then this one right here, it's around this way. This is a negative angle. And that is a clockwise rotation. So I know that we talked about basically positive and negative angles on the circle in geometry. We didn't get much into the ordered pairs and stuff, I don't think, with y'all, but should have at least gotten this far. Okay. We all good? Yes? Any questions about the vocabulary? You just got to know what we're talking about to get through this stuff. All right, so then we've got a quadrantal angle, which my guess is that's probably a new term. So if I ask you about quadrants, right, so here's my x and y axis. Which quadrant is this? 2. Okay, good, because we start here, right? 1, 2, 3. This cannot be anything that we're messing up anymore. 4. So if I draw an angle and I ask you what quadrant it's in, that's pretty easy unless the terminal side falls on an axis, right? If it falls on an axis and like this is my initial ray and this is my terminal ray, I mean, what quadrant would you tell me it lands in? None, right? It doesn't really land in one, right? Because that angle right there would be a quadrantal angle. So it is an angle in standard position with its terminal ray on an axis. So we need to be able to determine what it is. I don't want to just say it's a quadrantal angle because it is. If it lands here, well, if this is 0, this is how much? 90. So this would be the positive y-axis. So it's a quadrantal angle on the positive y-axis, right? This would be at 180. So it would be a quadrantal angle on what? Negative x-axis, good. And then this, what angle measure would this be? Got 90, 180, 270. And this would be the negative y-axis. And then 0 or 360 would be on the positive x-axis. Now, can I have an angle that's greater than 360? Can I wrap around and around and around? Yeah. So once I get to 360, I would just keep going. I could have a 583 degree angle. Just kind of spins around. We'll look at how to graph those and what all that means in just a second. Everybody good so far? Quadrantal really should be the only thing that's brand new to you because the top of this literally came from the notes I've already used with y'all. All right. So now we're going to look at angle measures based on rotation. And in order to do that, I need to move mine down a little bit. Because y'all have room at the top that I don't have. All right. So 1 degree. If we think about here we are at 0, right? This was 90. This was 180. This was 270. And then all the way back around to 360. So when I rotate, when we're talking about a rotation all the way around, if I start here and go all the way around, that's 360 degrees, right? Whole business. So 1 degree, which we can write as 1 degree, right? What fraction of a rotation is 1 degree? 1 over 360. It's 1/360th of a rotation. Does that make sense? So sometimes we have degrees, let's say it's like 52.3 degrees. Okay, well, yes, you can use them as decimals, but you can also make it more accurate in degrees, minutes, seconds. Have any of you used degrees, minutes, seconds in anything yet? I don't know if that's anything you've used in physics or anything yet. Okay, so instead of just using it as a decimal, it's kind of like saying, if I have 1.25 hours, right, is that 25 minutes? 1.25 hours? How many minutes is that over an hour? Think about that. It's an hour and 15 minutes, because 1.25 hours is basically 1 1/4 hours, right? And 1/4 of an hour is not 25 minutes, it's 15 minutes. So same thing here. We're going with 360. This is not in a, it's not a base 10 type of thing. So we have degrees, minutes, seconds. It's just a different way to look at how to break these down. So we're breaking them down kind of like time. It's not time, but it's the same kind of concept there. So we've got 1 degree. So 1 minute, to show that we have that, you put, it's a 1 and it's like an apostrophe. And so if you think of a degree as like an hour, which again, it's not really time, but you think of it that way, then there are 60 minutes in 1 degree. So that means that 1 minute is 1/60th of a degree. Then 1 second, it's going to be 1, and then like the quotation marks like that. It's kind of like inches and feet, the thing that you're doing there. And so there are 60 seconds in a minute still. That hasn't changed. So 1/60th of a minute. But 1 second is how much of a degree? Is it 360? It would be 60 times 60, which is 3,600. You have to divide by 60 twice. So if I had something that looks like this, if I had 12 degrees, 42 minutes, 38 seconds. So you might see something like that instead of a decimal. Okay, it's not exactly 12 degrees. It's somewhere between 12 and 13 degrees. The way this reads is 12 degrees, 42 minutes, and 38 seconds. And if I wanted to convert that to a decimal, it's not 12.4238, right? It doesn't work that way. Just like an hour and 15 minutes is not 1.15 hours. Doesn't work that way. Everybody okay with all that so far? We're not actually converting with this today. That's coming a little bit later, but you need to at least understand that it's there. And then I'm just going to rewrite our quadrants here so we have something to look at. I certainly hope that isn't anything we're messing up anymore. Maybe you never messed it up. That would be good. So we looked very briefly at a unit circle in geometry. And so that's what this is going to just describe a little bit. We're not getting too far into that today. But what a unit circle is a circle with a radius of what? One unit. Whatever that unit might be, right? Just has 1 unit. And we use that unit circle to help us understand how else we can look at angles. So what else can we look at angles with besides degrees? What's it called? What do you have to always change your calculator out of? Radians, okay? So a radian measure of an angle is the ratio of the length of an arc intercepted by a central angle and the radius of the circle. And 1 radian is about 57 degrees. So we're going to draw that over here. And knowing that it's about 57 degrees, right? So from here to here is 90. So about 1/3 of the way is 30, and about 2/3 of the way is about 60. So right, kind of a little bit below 60. I mean, we're not going to get perfect and exact. We're just going to get something that looks semi-okay. This is the length of the radius, whatever it might be. So is this, right? As that swings around. This right here is the intercepted arc. A central angle, remember, has the vertex at the center of the circle. This is its intercepted arc. So if this is going to be 1 radian, or about 57 degrees, then the length of this right here is 1 radian. So basically, it's kind of like an equilateral triangle, except it's not a triangle because that's part of a circle. Right? right? But that would be 1 radian. So if my radius is r, okay, or it's 1, let's say, how many radians would be in a full rotation? Think about that. How many times does the radius go around the circle? What is the distance around the circle in general? Like, what do you call that all the way around? Circumference, right? Right, so how would I find the circumference if I know what this is? 2 pi r. And if it's a unit circle and your radius is 1, how many times does it go around the circle? 2 pi. So the radius goes around 2 pi times. Does that make sense? And 2 pi is about 6.28, right? So it's not, I'm not saying this goes around 2 times. The radius goes around about a little bit more than 6 times. So all the way around, how many radians there are in one rotation is 2 pi. That's where the circumference comes from. The radius just happens to be 1, right? And so how many radians are in half a rotation then? Pi. Right? So your radian measures, although they can be decimals, and obviously the calculator is going to give you decimals and weird things like that, but they can also be, or most of the time you'll have pi values in there, okay, to give exact answers. We okay with all that so far? Okay, should have converted from degrees to radians and back and forth in geometry regardless of what level of the class you were in. Okay, so now I'm going to look at this. We're just going to name the quadrant containing the terminal ray or state that it's quadrantal depending on, what happens here. So if I have a 120-degree angle, okay, and you can look back up at your little picture up at the top where we had this in here. If this is 0, right, this is 90. So 120 is somewhere over here. So what quadrant's it in? 2. That's all we're really doing right there. Just understanding what quadrant it's in. Now this 415, right? That means I would start here. I would rotate around counterclockwise because it's positive. I'm going to go all the way around to 360, but I got to keep going. So I got to know what 415 minus 360 is, so I know how much more to go. What's 415 minus 360? 55. Okay. So if I make one full rotation and then another 55 degrees, what quadrant am I in? 1. So negative 20. What am I in? 4. Because I would start here, I would go clockwise since it's negative, and I would end up right here in quadrant 4. Then 270, what would it be? It would be quadrantal. And I have to state like what that is. If I'm here, then that puts me on the negative what? Y-axis. Everybody okay with all that? Good? All right, so now we're going to sketch these angles. Now, and when you sketch them, we're not getting out, protractors and making them perfect or anything, but you do have to have an idea of exactly where it goes. First of all, your initial ray is on the positive x-axis, no matter what. This is positive, so I'm going around counterclockwise. I'm going to go 135 degrees. So this is 90. What's 135 minus 90? 45, right? And if you just do that in your head, that's okay, but I just want to make sure you understand where I'm getting at. So that means I know I'm in this quadrant right here, but I don't get to just put my little point anywhere I want. 45 should be about halfway, right? So I would expect you to have your point about halfway. Okay, and again, we're not getting out measuring devices or anything, but if you just throw it over there and don't have any concept of it, that's not a good thing either. We'll put that in there. Then we need to be able to show how we actually got there, because there's more than one way to get here. I can get there by going this way, by spinning around a bunch of times, whatever. But all we did was we started here, so my little curvy arrow starts here, and then it points to the terminal side. For some reason, kids have trouble with that. I don't really understand why. Just make sure that it starts where you start and it ends where you end. You don't get to just like randomly put it anywhere, but it's showing the direction of rotation. Everybody okay with that? All right, so then let's look at this one, 495. So I'm starting here, positive x-axis. This is a positive angle, so it's going to rotate around. Well, I know I'm going all the way around. I got to figure out what 495 minus 360 is, so I know how much more to go. What does that give me? 135. So I should know at this point exactly where I need that to be, right? It looks pretty much the same. This is one of the many reasons why you've got to have this little arrow here, because I didn't get there the exact same way. I'm at the same spot, I just ran an extra lap, basically. So I started here, I rotated around 360, and then I kept going. So that it looks like that. Does that make sense to you? That shows the difference between those two angles. Because I should be able to look at this picture and be able to estimate that angle. Okay? I can look at that picture and I can kind of estimate it. Since we don't actually have marks on there, I couldn't tell you necessarily that it was exactly 135, but I should be able to kind of estimate where it is. We all good with that? Okay. All right, so then negative 60. I'm starting here. How do I handle this one differently? I'm going to go clockwise this time, right? And it's a negative, so I'm going to go this way. Well, from here to here is 90. So remember, about a third is 30, and then another third is 60. So it's about 2/3 of the way. Look like that. And then this time my arrow goes this way to show that it's a negative angle where I end up. Okay, everybody okay with all that? Any questions? Awesome. All right, so let's look at these. It says an angle has a counterclockwise angle of rotation and the terminal side lies in the third quadrant. Okay, so counterclockwise and the terminal side is in the third quadrant. Those things are all important. So we're going to draw a little sketch here. So here's my little X and Y axis. So I'm starting here, right? The terminal side, do I know where in the third quadrant? No, just somewhere in the third quadrant. So there we go. And it says it has a counterclockwise angle of rotation. Looks like somewhere like right there. Okay. And we are going to assume that it doesn't rotate more than once. I should have put in here that it has like a single rotation. So does this tell me something about the angle? Okay. So I want to know, what does this tell me about the Miguel, tell me what this, just being able to read that and sketch that, what does that tell me about the angle? Anything? Is it positive or negative? It's negative or positive. You tell me. How would I know if it's positive or negative? Okay, it's positive. All right. Can you tell me something about the measurement? Like, you can't tell me exactly what it is. We don't have the information for that. But can you give me a range of possibilities? What does it have to be between? Okay, so it's positive, right? Positive, and between 180 and 270. Everybody agree with that? And that tells me something. So we could also write it as an inequality, and we're going to use for the unknown theta, so it's like the circle with the line through it, to look like this. Everybody okay with that? All right, so let's look at the next one. You do this. I want you to go ahead and sketch this one out. An angle has a clockwise angle of rotation, and the terminal side lies in the first quadrant. Just go ahead and do that one on your own. So that's what my picture looks like. Y'all agree with that? Yeah? Okay. Then what does that tell me about my angle coding? What does it tell me? Positive or negative? Negative, okay. And what measurements would it be between? So let's think about this. I'm here, right? If I go from here to here, how far have I gone? 90, but it's a negative 90, right? And so then here, that gives me a negative what? Okay, and then here a 270. Okay, so it has to be between the negative 270 and what? What would, if I keep going, this is negative 270, what would this be? What's all the way around? 360. Okay, so it's between a negative 270 and negative 360 degrees. So then as an inequality, the negative 360 would actually go on the left because it's smaller. Okay? Everybody okay with that? We good? All right, so now we're going to draw a 245 degree angle in standard position. So if it's in standard position, it starts here, right? And then 245, well, I know this is 90 and this is 270, so it's going to be somewhere in here, but I need to do this 180. No, I'm sorry. That's not what I want to do first. I want to do 245 minus 180, so I know about where to put it. What's 245 minus 180? 65. So that means I need to go 180 degrees plus about 65 more, so that's about 2/3 of the way. Looks something sort of like that. Okay. So this right here is my 245 degree angle. So then it says, what is the measure of a coterminal angle? All right, so what is a coterminal angle? Evelyn. Not here. Katie, what is a coterminal angle? What does that mean? Okay, so how is a coterminal angle related to this angle? But like physically, how's it related? What's word-wise, definition-wise? What does it say about a coterminal angle? With the same terminal side. So I got to get to the same place, but I got to get there a different way, right? So instead of going this way, could I go this way? Yes? Okay. So if I did that, what would the measure of that angle be, Katie? Negative 115. Good. Okay. Everybody okay with that? Then it says, what is the measure of the reference angle? So I first want to know what is the reference angle. Flung. Okay, it's a positive acute angle. Any positive acute angle? You said it's a positive acute angle, so it could be, it's 30, like any positive acute angle? How do I figure out which a positive acute angle it is? Okay, well, it's always from the terminal side, the shortest way back to the x-axis. So in this case, it would be the negative x-axis, so I'm going this way, right? So there's my reference angle. It's the shortest way back to the x-axis. What would that reference angle be? Okay, so if I'm just going from the terminal side back to the x-axis, 65, positive or negative? Negative? Tell me again what a reference angle is. It's positive. So even though to get here, I would have to go clockwise, when we're talking about the reference angle, it is always a positive acute angle. So this is 65 degrees. Now I want you to look at these two sentences for B and C. Okay, I know one of them says coterminal and one of them says reference. But besides the fact that these two words are in there and they're different, what else is different in the two questions? Well, not the answers, the questions. Yes, one says of the and one of them says of a. You see this a, the? Those words, as tiny as they are huge because they tell you something. How many possible answers do you have for this one? One, the reference angle. That is the reference angle. This says a coterminal angle. So what does that imply? There's more than one, right? How many are there actually? There's an infinite amount of them, okay? An infinite amount of them. Because isn't there an infinite amount of ways I could get here? Like I can go this way or I can go that way. That's most likely what we think of first. But couldn't I start here, wrap around, and then get there? And couldn't I start here, wrap around, and get there? And couldn't I wrap around like 30 times and then get there? Or an infinite amount of times? Like there's an infinite amount of coterminal angles. There's only one reference angle, but there's an infinite amount of these. That's most likely what would pop in your head first, and that makes sense. But just understand that there are more, okay? We good? All right, so let's do this one and let's look at that. We'll think about that as we do this one. Negative 200 degrees. So I have one side on the positive x-axis. Negative rotation means I'm going clockwise. Negative 200 means I'm in which quadrant? The second one. Because I would go 180 and then another, how much more? 20. So I'm only about right there. So this right here is my negative 200 degree angle. Okay. So then it says, what is the measure of a coterminal angle? Okay. Well, let's do the easiest one first. Let's just think about what this one would be. What would that one be? 160. So this would be a positive 160. All right, so give me another positive coterminal angle. How could I figure that out? 520, add another 360, right? I'm here, add another 360, and that would give me 520. That works. So give me another negative, or a negative coterminal angle. Negative 560, because here's negative 200. If I go another 360, I'm there again, so negative 560. And I know it only asks for one, and if that's the question on the homework, you would only have to give one. I just want you to understand that there is more than one answer. Okay, we all okay with that? All right, so reference angle, okay? The reference angle, which means I only have one possibility of an answer here. And it's always the shortest way back to the x-axis. So I'm going this way. And most of the time, you've already figured that out because we had to figure out how much farther we had to go anyway, so that's why we use the reference angles a lot. What would that measurement be? Just 20. It's always acute, always positive. Everybody good? Any questions? Okay. Now, do all angles have both positive and negative coterminal angles? Yes, right? I'll have positive because I could go either way to get there. So yes, how would I find them? What's the easiest way to find them? By adding or subtracting. How much? 360. Ah, I could spell. Subtracting multiples of 360. And then, are reference angles always positive? Yes. So we're going to write a little bit more here. Yes. Always positive. always, what else? Acute. Yeah, and, yes, good. Always positive, always acute, and always created by terminal ray and x-axis. And that x-axis thing is so important because there are times where you're going to want to draw it to the y-axis to draw a picture. That is not what the reference angle is. Okay? Always with the x-axis. All right, any questions? Lots of vocabulary today. All right, so we've got to knock out the vocabulary, and then we'll get into the more cool trig stuff that kind of starts to tie everything together a little bit better. Okay, we all good? Any questions? All right, go ahead and glue that in, and I'll give you your assignment.